Welcome back to Cloud 42, I'm James. Well, you may have noticed that I went a week or two in there with no new video. Not to worry, I'm not dead, obviously. Long story short, my wife and I built a home gym back in March using just whatever equipment we could get our hands on at the time as everything was shutting down. And what we've discovered over the last few months is that we really enjoy working out at home instead of having to go to the gym. So we decided to get some quality equipment and do this thing right. And as we were able to find things in stock and as things were delivered and as I started adding up the accumulated weight in my head, we realized that the upstairs bedroom we were using as a gym was just not going to be structurally suitable in the long run. So we decided to move everything down to the garage. And as with most things in my life, this started out with a gym membership and a global pandemic and ended up at the CNC mill. Let's go take a look. Well, I think everything in life that's worth doing always starts with a CAD model, and that would include a squat rack and deadlift platform. And so this is what I'm building. This is a Rogue half rack. And I've got kind of illustrations here of a loaded squat bar and a loaded deadlift bar just so I could get an idea of how all this stuff was going to fit when I was designing the platform. So the platform underneath this consists of 3 sheets of 3/4 inch plywood, a couple of sheets for the base, and a sheet with finish on it to stand on that's 4 feet wide, and then on the side strips of horse stall mat to drop the deadlift on without damaging the floor. Gives it a little bit of cushioning. Now, I'm going to be building this in the garage on the concrete floor, and all of this is going to be screwed together, but I need a way to anchor the squat rack down to the platform so that it won't move when I walk in a heavy squat or, rack a heavy bench. And so I need a way to attach it to the floor. And Rogue actually makes a mounting foot, and this is the one that they sell. It's just a piece of bent 3/16 steel that bolts into 2 of the holes. These are 5/8 bolts that bolt into the foot and then provide a place to put in a concrete anchor. But I'm not planning on anchoring this to the concrete. I'm planning on anchoring it down to the wood platform, which is only about 1.5 inches thick. And I just can't imagine a 1/2 inch or a 3/8 inch lag screw going into 1.5 inch thick piece of wood. That just doesn't seem viable. So I wanted to design my own foot that used an array of small wood screws to hold it down to the platform. And so that's exactly what this is down here. This is a bracket that I designed up. So this has got holes for a number of screws, and I'll use 1.25 inch drywall screws actually to hold this bracket down to the platform. And then it'll bolt through one of the normal holes in the foot with a 5/8 bolt. And so if we go in here and hide a couple of things, hide the nut and the bolt, you can kind of get an idea, if I can find the right nut, of how this is. So this is actually just made from a piece of 2-inch angle iron, or 2-inch angled aluminum is what I'm going to mill it out of. And so it's already got this radius in it, and the bulk shape is there, so we don't have to hog out a bunch of material. We just need to cut a slot here because I don't know exactly how high this is going to be. And if you can't make something perfect, you make it adjustable. So I'm going to make that so that the height is adjustable, and then once it's bolted in place and flush with the ground, I'll drive in 9 screws to hold it. So to machine this, we're just going to need to pocket that out. We're going to need to do the perimeter, and then we're going to need to put it in a second setup to drill all the holes and contour around the other side. So I have a model here for the cam, and this is going to be pretty straightforward. Before I pocket out this slot, I do want to go ahead and drill. Using this new spindle, I'm not that familiar with it. I'm not that familiar with how a helical entry is going to work. So I'm going to go ahead and just use my spotting drill, put in a 1/4 inch hole first to make room so that there'll be less pressure on the helical entry, and we'll see how it goes. Maybe in the long run, I won't need to do that. And then we'll do a 2D adaptive, and this will just helical entry in. There's already a pre-drilled hole, and then it will accelerate and then hog out the rest of that material. And so that'll be the first time we'll see this spindle running full speed. It's 54 inches a minute at 12,000 RPM with a 3-flute cutter hogging out material. And so I'm hoping that's going to be pretty spectacular, but not too spectacular, if you know what I mean. And then there's a contour, because the adaptive is going to leave about 10 thou, and I'll do a contour to clean up any of the facets left from the adaptive clearing. And then we'll do an adaptive clearing operation on the outside, just coming through the 1/4 inch thickness here, just to contour it around. And then we'll do a second adaptive deeper, because I want to make sure that the end mill is only meant to side mill down 1 diameter, and I want to go about 2 diameters so that we take care of this this filleted area and get that trimmed to width, so when we flip it around in the other setup, we can only just do 1 pass to clean up the other 1/4 inch thick flange. And then do a final contour at that full depth around the outside to smooth it out and clean it up. Then we'll take that out, flip it over into a second setup, and do the same kind of adaptive operation, except we only need to do it at 1 depth because the rest of this has already been cleaned up. Then contour around the outside to clean that up, and I'll spot drill and drill all of the holes. Now, I probably don't need to spot drill this because it's not that critical, but the tool changes are quick, so I'm going to go ahead and do it and just get some experience with this new spindle and how it behaves. I'll probably want some countersinks on the bottom side of this. I'm not going to try to mill those. I'll just run it over to the drill press and do those by hand. So I think that's it. Let's go out to the mill and see how this goes. This is the material that we're going to use. This is just a 2 inch by 2 inch piece of aluminum angle extruded with 1/4 inch thick sides. I'll just drop that in the vise, center it up, though it really doesn't matter, and clamp that down firmly. And the first side we're going to do is the slide that has the slot in it, but the first thing we need to do is zero up on this back edge of the part as shown in the setup sheet. And for that, we will need the Heimer. Okay, according to the setup sheet, the first tool is going to be a spotting drill, tool 2. And we're just going to use the spotting drill to create an opening for the helix entry. Do we really need to? Probably not, but I'm still getting the hang of this spindle and still getting a feeling for what it can do, and I'd rather have a clearance hole just to make the entry easier. Okay, and then the rest of this program is going to be tool 15, which is a 3-flute end mill. And this is a Lakeshore Carbide 1/4 inch of variable flute end mill coated for aluminum. Now this thing is going to move really, really fast, and this is a little bit weakly supported because we're just dealing with the rigidity of the aluminum here. I think it's going to be okay for this particular cut, just because the loading is not that great. We're only taking 1.5 thou per tooth, and with this thing running at 12,000 RPM, and with the variable flute end mill, I think it's all going to even out, and it should run pretty smoothly, even though we have a little bit of a lack of rigidity. But I guess we're going to find out. And let me close part of this. I can't close it completely or you won't be able to see, but I'm expecting just a snowstorm of aluminum from this. Well, that went pretty well. The surface finish on that is very, very nice. And yes, there was a snowstorm of aluminum. Looks like I caught most of it inside the enclosure, but there's a little bit out here on the floor. It's okay, I'll vacuum it up later. It was worth it to get the shot. Okay, that all came out nice and clean. I'm pretty happy with that. You can see we cleaned up this side all the way back to the base here and down, so we cleaned up that corner. And so then when we flip it to do the drilling in this direction, it'll give us a nice place that we can indicate. Let me wipe the chips off this and knock off any burrs. And let's put this back in the vise. Now we need exactly the same drill. Let me grab the Heimer and we'll find this back edge. Now we don't need to re-indicate the Y because that's controlled by the fixed jaw of the vise, but because we took the part out and put it back in, we will need to indicate the X, and I'll use these machine surfaces on the end to do that. And as long as I got the Heimer in there, I'll go ahead and re-indicate Z. Should be exactly the same. No, it won't, because we took a little bit off of this front edge, which is now on the bottom of the vise, so the Z height will be a little bit different, even if you aren't accounting for the differences in the extrusion. Yeah, and just out of curiosity, the Z0 I'm showing here 0.0049. So we did take about 5 thou off of the other side of the part, which is why the Z is now about 5 thou lower. Okay, the first operation is back to tool 15 to contour adaptive and contour the outside edge. Next up is the spotting drill to spot the holes. And now finally a number 15 drill. Get this drill out of the way so I don't cut myself on it. Of course, that's never happened before. And let's take a look at what we got. Those look like holes. Got a little bit of an edge on here. Let's see, how do we do for alignment between the top and bottom, between the two setups? I can see the joint there. I can see this, the edge. I can see when I came across this last time, I touched both surfaces. There is something there. Might be a thou, might be two. It's hard to tell. And on this side, it's the other direction, and yeah, it's pretty similar. A thou or two, probably misalignment. That's not too bad. I can live with that on a part like this. If that were really critical, I would try to find a way to do more of the machining in a single setup. Okay, so these have got some burrs on them, which is to be expected from drilling. I will take this over to the drill press and just use a countersink. I would do it here in the mill, but I don't have a quill anymore. I deleted the quill when I put this spindle on. So I'll just go over the drill press with just a countersink and just come in and just clean up all these holes. And then I will brush the rest of this down with Scotch-Brite. I actually have a buffer that I haven't set up yet. I'm looking forward to having that with a Scotch-Brite wheel. That would be great for this. But I'll just do this by hand, and we'll go put this on the rack and see how it works. Well, this is the squat rack. I will apologize for the weird lighting over here. I have the lighting set up in the shop behind me, but I don't have the light set up over here in the gym yet. So this is just a Rogue half rack, and it's sitting on a platform that I showed the design of earlier. So this is 3/4 inch ply with horse stall mats on the sides for deadlifting. And then there's a second layer of 3/4 inch plywood underneath it just for stability. And the whole thing sitting on a floating floor sub layer, which is a 2mm foam with some insulation and vapor barrier. And I've already got the feet installed here on the rack. And you can see they're just attached to the rack leg with a 5/8 inch bolt through with a nylon lock nut and a washer. And then the screws that hold it down are these. These are just 1.25 inch drywall screws. And there are 9 of them in each foot, just driven right down into the plywood. And that seems sufficient to hold it. The whole thing's held down with 4 feet. There's one there, one on the back, and then the same thing on the other side. And I'm pretty pleased with how these turned out. After kind of hitting them with some Scotch-Brite, the edges are kind of soft, so if I'm ever out here squatting in bare feet, I'm not going to cut myself on them. And I'm pretty pleased. It holds the squat rack down nice and solid. Better than I expected, actually. And that's the mounting foot. I've had a chance to use the rack a couple of times since I installed them, and I'm pretty happy with it. It seems nice and stable, so I think that is going to work. I did run into one other problem when I was installing the rack down here on the wooden platform, but that will be the subject of a future video. If you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.